Hey everyone, something totally new today in the thermochemistry world, and it is Hess's law. So what is Hess's law? It pretty much says that the enthalpy of the sums will equal the whole. What are the sums? Okay, the sums could be the enthalpies from the bonds or from the enthalpy released from a certain product or a compound. It could be from the bonds. Okay, this is what Hess's law tells us. So pretty much what we're going to be doing is we're going to be looking at a bunch of enthalpies for reactants and products, and then we're going to be subtracting those from one another in order to find our total enthalpy. So what we're pretty much got to know is delta H equals delta H of products minus delta H of reactants. So what I'm going to do is I'm going to go ahead and put up an example for you guys, and we'll get right into this Hess's law of enthalpy of products minus enthalpy of reactants. Alright everybody, so this is a Hess's law problem that you will see. They will give you a bunch of these known enthalpies of formation. It says H sub F, that's enthalpy of formation, for all these compounds. Okay? And what they'll want you to do is they'll want you to take those known enthalpies of formation and find the total enthalpy of a certain reaction. Well, remember, to find total enthalpy, we just take delta H equals delta H of the products minus delta H of the reactants. Okay? So all we're going to be doing is we're going to take the enthalpy of all the products and subtract all the enthalpy of reactants. If you see coefficients in front, like here, you're going to have 3 of those enthalpies. Okay? Biggest thing here is just organization. If we don't organize our enthalpies, we could have a calculator error and it can goof up everything. Okay? So let's go ahead and lay this out and find our products. So I'm going to start over here, and let's look at my products. My first product is Al2O3. There's only one of them, and Al2O3 is negative 1676 plus my next product enthalpy, which is AlCl3, which is negative 703, plus my next product, which is NO. Okay, NO's is 90, but I have 3 of those, so I have to do 3 times 90. Okay, makes sense. 3 times 90. Plus my waters. There's 6 waters. 6 times negative 242. 242. Okay, and there are all my products. Okay, I put them all in parentheses, make them all together, put that in the calculator, and you got this nice number. Just set it off to the side. Okay, and then we'll have to subtract all the enthalpies of the reactants, which are 3Al and 3NH4ClO4. So I look at here and I say, oh man, there's no aluminum. Okay, some elements don't have enthalpies. Okay, aluminum, why wouldn't it have an enthalpy? There's no bonds. There's no bonds in aluminum to release any enthalpy or absorb any enthalpy. So no need for aluminum. But 3-ammonium chlorate sure does have one. Okay, and there's 3 of them, so it'll be 3 times negative 295. Okay, so now we have all of our products there on top, minus all our reactant enthalpies. We go ahead and we solve for that, and we should get an answer of negative 2,676 kilojoules per mole. And then I might go ahead and ask you, is this exothermic or endothermic? And you would say exothermic because it's negative. Does it absorb heat from the surroundings or release heat from the surroundings? Release heat. Okay, if I put this in a beaker and this reaction happened, would the water, or would the beaker get hotter or colder? Beaker would get hotter, right? It's going to release heat, those bonds are, and it's going to make the beaker hotter. Okay, so let's do another example here. Alright everyone, here's another example, a little bit different from that last one. So here, I gave you a reaction up top, but you'll notice that in the product side, I gave you an enthalpy, okay? I gave you some sort of enthalpy there that gives you the total heat for that reaction. And then we have some enthalpy heat of formations for CO2, H2O, and now I don't want you to calculate the enthalpy of the whole reaction, because they already gave it to us. I want you to find the enthalpy of formation for C6H12O6, which just happens to be one of our reactants. Okay? So once again, we are still doing delta H equals delta H of products minus delta H of reactants. But in this case, we don't have delta H of reactant. We need to figure that out. Okay? So let's go ahead and write down what we know. Delta H for the whole reaction, 2800. Am I forgetting to do something here? Yes, right? What should 2800 be? Should it be positive or negative? Negative, right? Remember, heat is a product. That means heat was released at the end. So it'll be negative 2800. Delta H of products time. Let's figure those out. Okay, our products are CO2 and H2O. We have 6 H2Os, which is going to be 6 times negative 285.8 plus the other reactant. Oh, I did water first. Sorry, guys. Okay, let's do it for CO2 now. Okay, plus 6 times CO2, which is negative 393.5. So we got our overall, we got our product enthalpy. Now we just need to find the reactant enthalpy. Okay, you might be thinking, wait, what about O2 there? O2 gas also doesn't have an enthalpy. It's like aluminum, it's 0. Okay, so if you see something like this and they don't give you enough information, you could assume it's 0, but O2 gas is pretty commonly 0 and anything that's by itself. But you'll see that in other examples. So let's go ahead and let's solve what we can. I'm going to go ahead and I'm going to simplify that guy as much as possible. So I'm going to take 6 times negative 285.8 plus 6 times 393.5, and I got not the right answer because I forgot to put negative 393.5. There we go. Now I got negative 4075.8. Okay, so I've simplified this a little bit more. Minus delta H. I'm going to add 4075.8 to both sides. Okay, and I'll simplify once more. So 2800 plus 4075.8. Negative 2800, I don't know how to type into a calculator. The right page of 28 to 1275.8 equals negative delta H, and then we got to get rid of that negative. So let's divide by negative. Our delta H for our C6H12O6 was negative 1275.8 kilojoules per mole. Okay, that's the most difficult it will get. Okay, so that is Hess's law, just the beginning. Next video we'll go over Hess's law, where it's kind of like a puzzle and we're matching up reactants and products.